Hello, I'm Dr. Jae Chun, a gastroenterologist at Severance Hospital, Yonsei University, Korea. I am one of the co-authors of the study regarding FTO variants in East Asian IBD patients. Thiopurine and its prodrug azathioprine has been used in anti-inflammatory, anti-cancer, and immunosuppressive therapies for a long time. Thiopurine methyltransferase enzymatically converts mercaptopurine to 6-methylmercaptopurine, or 6-MMP, diverting metabolism away from thioguanine. Based on this mechanism, several serious adverse effects are anticipated, including leukopenia, GI troubles, and arthralgia. As our group reported in 2009, we described the association of TPMT and ITP genetic mutations with the adverse effects of thiopurines. However, we did not find any association of TPMT and ITPA genetic mutations with thiopurine-induced leukopenia. A recent report suggested that NUT15 mutation is strongly correlated with early leukopenia in Korean CD patients. However, some of them cannot be explained by TPMT mutation or NUT15 mutations. Thus, we aimed to identify another novel genetic factors associated with thiopurine-induced leukopenia in patients with IBD. First, we carried out GWAS in the discovery cohort with the aim of discovering novel variants that confer sensitivity to thiopurine leukopenia. From a total of 273 coding variants, we identified 48 non-synonymous variants with a mean allele frequency more than 1%. Among these coding variants, a missense variant in FTO showed the strongest association with thiopurine-induced leukopenia. Moreover, FTO PA134T was located within a single LD block containing the FTO intron 3 variants, RS169525570. As you can see in this figure named A, FTO A134T was observed in 5.1% among 842 healthy Koreans, and other FTO coding variants occurred at a genotype frequency of less than 1% in Koreans, and did not appear to be involved in thiopurine-induced leukopenia. In the figure named C shows the genotype frequencies of 4 loci significantly associated with leukopenia in the discovery cohort. Because the heterozygous FTO variant encoding PA134T was associated with thiopurine-induced leukopenia, we examined whether FTO variant PA134T inhibits the function of FTO wild type. Next, we performed multivariate analysis using demographic characteristics. Interestingly, the results indicated that FTO and RUNX1 genotypes are more significant determinants for leukopenia development than demographic characteristics. Data from the replication and combined analysis confirmed the novel association of FTO PA134T or RS79206939 with thiopurine-induced leukopenia identified in the discovery cohort of this study. In our in vivo study, we found that the decrease in white blood cell count was more profound in both FTO hetero and FTO knockout mice. Similar results were observed in experiments with 6-mercaptopurine. With these data, we found that FTO knockout and FTO heterozygous mice were more susceptible to thiopurine-induced myelosuppression than wild-type mice. In summary, what we found was that we performed genome-wide association study that identified 2 loci associated with thiopurine-induced leukopenia. High throughput targeted sequencing indicated that an FTO PA1340 is associated with thiopurine-induced leukopenia and was further validated in 2 replication cohorts. This FTO mutation reduced the FTO activity by 65% in the nucleotide demethylase activity. In vivo experiments revealed that FTO knockout and heterozygous mice were more susceptible to thiopurine-induced myelosuppression than wild-type mice. How might it impact on clinical practice in the foreseeable future? We provide evidence that FTO PA1340 is associated with thiopurine-induced leukopenia in patients with IBD, and these results can provide a potential pharmacogenetic biomarker for thiopurine therapy. Thank you for your attention.